All right, so for today's deep dive, we're looking at the unsung heroes of IT, the smallest but maybe the most critical pieces of infrastructure out there.
Exactly. We're talking about environmental monitoring.
Specifically for those places everyone forgets about, right?
Yeah.
The server closets, the unmanned remote sites.
hmm And our sources are centered on one particular device, the NTI E-MICRO-TRH.
And the mission here is to really get our heads around how one tiny specialized unit can provide, total protection. It feels like a shortcut to really smart infrastructure management.
It is. Because when you've got critical gear in a cabinet somewhere, you can't just put a thermometer in there and call it a day.
Yeah.
The core idea, the real necessity, is holistic monitoring.
Yeah.
You need to know that your system's health is directly tied to its environmental stability.
So that server failure you're worried about might not be a hardware flaw at all.
It's often an environmental event you didn't even see coming.
Okay, so let's unpack that. What kind of conditions are we actually talking about? It's more than just heat, I assume.
Oh, way more. You're looking at the silent killers. Temperature, of course. Humidity. But also power status. Physical intrusion.
Like someone opening the cabinet door.
Exactly. Smoke. And the really big one, liquid water presence.
And how does a small box even manage all of that?
Well, that's the clever part. It has its own temperature and humidity sensor built right in, but the real power comes from its external ports.
The two dry contact input.
Right. You can plug in a flood sensor, a door contact, pretty much anything. It stops a slow drip from becoming, a total disaster.
And they're hot pluggable.
Hot pluggable, so you can add or swap sensors without ever powering down the unit. It maintains that continuous uptime.
Which is always the top priority. But
Yeah.
you said it's not just passively sensing, it's more proactive than that.
That's right. That's what we call the control layer. The unit is actively monitoring pinging up to 4 other devices on your network.
So like my main router or a critical switch.
Precisely. If one of those devices fails to respond to the ping, the NTI unit sends an alert.
Even though the problem isn't environmental at all, it's a network issue.
It combines both. It gives you a single view of network and environmental health.
So, okay, it detects an emergency, a flood, a network outage, whatever.
Yeah.
How does it scream for help? How fast does it get the word out?
The alert mechanisms are really comprehensive. You've got email, of course, post to a web page, and network management traps, SNMP.
Can it text you?
It can. You configure it through an email to SMS gateway, and the flexibility is huge. You can set up 32 different individual alerts.
Wow.
Or you can create one complex smart alert.
What's that?
It only triggers if multiple things happen at once. Say
Right.
the temperature goes up and the door is open. It helps eliminate that, alert fatigue.
That makes sense. So for our more technical listeners, how does this actually integrate with the bigger IT world? Does it play nice with other systems?
Absolutely. It's highly pollable via SNMP, all main versions, V1, V2C, V3. So it works out of the box with things like Nagios.
And for developers.
There's an HTTP REST API. You can pull sensor data and you get a clean JSON response back. Super flexible. Plus, security is baked in. HTTPS, TLS 1.2, AES, 256-bit encryption. It's solid.
Okay, let's pivot to resilience. This thing is the last line defense in some remote closet. How does it stay on if the building power fails?
That's a great question. The necessity for this comes down to the cost of downtime. This system is built for power diversity. The standard model has dual DC power inputs.
With two separate power sources.
Yeah, if one fails, it automatically switches to the other one. No interruption at all. It even intelligently draws from whichever source has a higher voltage.
And then there's the upgraded model, a TRHP. That adds power over Ethernet.
Right, which gives you triple redundancy. You've got the 2 DC inputs plus PoE. The expectation for uptime is just massive.
Do we have a number on that? An MTBF.
We do. The mean time between failures for the standard E-MICRO-TRH is 628,394 hours.
Wait, hold on. 600, what is that in years?
It's over 71 years of expected continuous operation.
71 years.
Right.
Okay, that's a serious commitment to reliability. So, tying this all together, what's the takeaway? It seems like proactive monitoring with small, robust devices like this isn't a luxury anymore.
No, it's the absolute backbone of business continuity, especially with edge computing. You have to prevent the environmental incident before it causes a catastrophic failure.
You're not just reacting to a server crash.
You're preventing it from ever happening, which brings up a final thought for you as you consider your own critical spaces.
Okay.
If a device this small has built-in power redundancy, deep encryption, and active network monitoring, What unexpected environmental weak spots might you be overlooking right now? Think about that liquid detection. It's the silent killer people forget, and it might just be the one thing that could save you from disaster.